Okay, good morning. Welcome to
FamilyMath 580.
FamilyMath number 580. We are returning to Grant Sanderson's derivative video. So last time you drew a curve of distance versus time.
Yeah.
Remember that?
Yep.
Okay, I want you to draw another one, and we're gonna go through the same exercise. Okay, so this is the car starts, and then you're marking out how much distance it traveled.
Okay. So the car doesn't gain much distance at the beginning, but then when it picks up speed, it gains a lot of distance, and then when it slows down, it reaches its maximum distance here, and it just stops like that.
Okay, so that is a graph. That is one graph of distance versus time.
Yeah.
For a car. And what was he doing in the video? What was the question he was talking about?
When does the car start moving?
Okay.
What was the derivative of this function?
Well, actually, he asked both of those questions. What was the interesting thing about the question about when does the car start moving?
Well, he was wondering if it started at t equals 0. And if it didn't start there, then when would it start?
Yeah. What's interesting about t equals 0?
It's just the first time is not, it's just at the starting point.
Okay.
It shouldn't be moving.
Something else was interesting about t equals 0.
Well, the equation that you had from the distance time equation that you had involved dividing by 0 at t equals 0.
Not quite the distance time. The equation he was talking about for the instantaneous velocity would have involved dividing by 0. So that was kind of a small problem.
Yeah.
But the other thing, you are correct. He was interested in finding something called the derivative, which involves looking at the velocity of this car over time. So what does that mean? What does the velocity of the car over time mean?
Well, it means how fast it's going.
Okay, so for the graph that you've made here, why don't you show me what the velocity curve looks like?
Well, it kind of looks like it rises and it goes back down like this, and it ends at the bottom.
Okay, what's the value at the beginning? How fast is the car going at the beginning?
0.
And how about at the end?
It's still 0.
Okay, why?
Because the car has to stop.
The car's stopped. And what about in the middle? What's going on here? Why is this velocity curve up high in the middle?
Well, because it's going faster and getting more distance.
It's going faster in the middle. Okay. So can you take the marker and tell me something else about this picture? Some new geometry in this picture that's not there now that Grant was talking about?
Well, like, what do you mean?
Well, he mentioned other things. The derivative had other interpretations.
Well, it's like sort of the rise over run approximation
Okay.
of that.
So just pick a point anywhere on the curve, doesn't matter.
There's gonna be a couple different values, but like here where it's pretty steep,
Okay.
and that you sort of did this, and you do this. This is a really small value going over and a really small value going up.
All right.
And then you can sort of approximate by finding the slope of this line passing through these 2 points.
Okay. So if the slope, if you're talking about going over a small distance in time, this has units of time.
Yeah.
And this has units of distance. And the slope, which is the change in distance, which he calls ds. So, yeah, I better be careful. He used s for distance. Actually, it's a very common variable in math for distance. S, because d has a different connotation. ds over dt. What are just the units of this? The change in distance divided by the change in time, which is the slope. What are the units of that?
Well, that's in speed, or velocity.
More precisely, the units.
So distance over time,
Distance over
miles per hour.
Yeah, miles per hour, or what's another?
Kilometers per hour?
Kilometers per hour.
Miles per minute or something?
Yeah,
Feet per
exactly.
second.
Feet per second, meters per second. So the units are units of velocity, and that's the slope.
Yeah.
Okay.
Yep.
And show me some other slopes on the
Well,
graph.
when you're just starting out here, the slope is shallow.
All right.
And then if you're over here, the slope's pretty much non-existent, just 0.
0.
Yeah, interesting. Okay, great. So let's move on to the second part.